Hello, friends. Today we're going to be learning about inequalities. Inequalities, you probably heard of inequalities. Notice the word in here. Inequalities. Excuse my handwriting. Equalities is when you have something on the left side equal to something on the right side. But we are looking at inequalities when something on the right side is greater than or less than the thing on the right side. So, what are the different types of inequalities? Well, we are looking at competition math today, and things like the AME, AMC, mostly MAA competitions. This is known as a field of competition math, and it's quite different from the standard curriculum that you might learn in your school. So, what are the main inequalities? Well, it's important to know some things also called means. I'm sure you've all have heard of averages, right? Averages, kind of synonymous with means, right? But not exactly. There are different types of means, and this QM, AM, GM, HM inequality, which may seem intimidating at first, is really just an inequality. We have lots of relations here. The QM is greater than or equal to AM, and greater than or equal to GM is greater than or equal to HM. How about we break down each of these individually? QM. This is the quadratic mean. Quadratic mean. And this takes the quadratic mean of a sequence of numbers a1, a2, an. A1, A2, an they're just variable names, right? We have a sequence of length n, and the quadratic mean of these numbers is the square root of a1 squared plus a2 squared plus a3 squared all the way to um plus a n squared, all divided by n, and then square rooted. Note that the square root encompasses the whole thing, right? It's important to keep that in mind. This is the quadratic mean. It has some applications, for example, the distance formula. Note that this looks sort of similar to the distance formula, right? Now we can move on to the next mean, AM. This is by far the most common one. AM stands for arithmetic mean. Now, when you say, hey, friend, what is the average of these numbers? 1, 2, and 3. You would probably respond 2 by adding up every individual number, 1, 2, and 3, and then dividing by the total number of numbers, 3. Then you get 2. This is exactly what AM is, or arithmetic mean. We have a sequence of numbers A1, A2, all the way to AN. Arithmetic mean is A1 plus A2 plus all the way to AN divided by N. Now this is kind of similar to the quadratic mean, except we don't have the square root and we don't have the squares here. That's not happening. So this is arithmetic mean, by far the most common one. Let's move on to GM. Geometric mean. You could say it's similar to geometry. There are some connections between the two, but that's not really what we're going to focus on. We're going to be focusing on what GM means. GM, with our sequence A1, A2, all the way to AN, is the product of these numbers, A1 times A2 times all the way to AN. The product of all these numbers, right? And then we take the nth root of it. Or in other words, this is A1 times A2 all the way to AN to the power of 1 over n, right? This is geometric mean. Note that the nth root just means what number to the power of n, or when multiplied by itself n times, is equal to the inside expression. So now we can move on to HM. Harmonic mean. This has many real life applications in speed. When you're considering things like speed, how fast you do something, or how fast you move, harmonic mean is good for finding things like your average speed. If you walk to 1 kilometer at a speed of 5 miles per hour, or I guess 1 mile at a speed of 5 miles per hour, and then you walked another mile, but at a speed of 10 miles per hour, what was your average speed all throughout? You can't just take the arithmetic mean of these numbers. The average speed is not 7.5 miles, but instead, the average speed is the harmonic mean of 5 and 10, and I'll show you what the harmonic mean is. With our sequence A1, A2, hold it and the harmonic mean is we take n, the number of terms, all divided by 1 over A1 plus 1 over A2 dot 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 all the way to 1 over AN, right? This is the harmonic mean, and it's useful for finding things like average speeds. Now we can get into what AMGM and QMAMGMHM relate to each other. Remember at the start of the video, I said QM is greater or equal to AM is greater than equal to GM is greater than equal to HM. This basically says that the the quadratic mean, the QM, of any sequence of numbers is greater than or equal to AM, the arithmetic mean, of the same sequence of numbers is greater than or equal to the same geometric mean, is greater than or equal to the same HM, harmonic mean. These are only all equal when the sequence of the numbers is all the same number. For example, 5, 5, 5, 5, a bunch of fives. These are all equal numbers. All four of these means will be equal. So now, how can we use this in some problems? Well, before we get into that, we need to learn one more inequality, and it might seem a little scary at first. The name is also scary. This is called the Cauchy Schwarz or Schwartz, but there's no T. Inequality. For fractions, this is really important for competition math. However, I've heard of similar names for things like linear algebra, which we're not going to be doing in this course. The Cauchy Schwarz inequality says that if we have a1, a2, dot dot dot, an, then a1 squared plus a2 squared dot 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 plus an squared, and I'm just going to make this a bit smaller, and then we're going to introduce another expression sequence b1, b2, all the way to bn, when a1 squared plus a2 squared plus an squared times b1 squared plus b2 squared all the way to bn squared is multiplied together. This is greater than or equal to, move this to the side a little bit. This is greater than or equal to, no, greater than or equal to. This is greater than or equal to a1 b1 plus a2 b2. I'm just going to move my marker to the side. Dot 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 plus a and bn, the product of an and bn, mind you, I didn't write the product sign, but that's what it indicates, squared. a1 times e1 plus a2 times e2 all the way to an times bn, all squared. This inequality is very useful in many problems where they minimize one thing or the other. If this right side is constant, then the left side's minimum value is the right side. We know that the left side is greater than or equal to the right side, and the smallest we can get is equal to the right side. So now let's try this in some problems. We want for real numbers A, B, C, D. We want to minimize A plus B plus C plus D times 1 over A plus 1 over B plus 1 over C plus 1 over D. Pause the video and try to figure this out using the inequalities we just learned before trying this on your own. It might be a little difficult, but there's a way with AMGM and a way with Cauchy Schwarz. Okay, now we can get into learning both solutions. We can start with AMGM. The arithmetic mean of A, B, C, D is greater than or equal to the geometric mean of A, B, C, and D. So what is the arithmetic mean of all of these? It's A plus B plus C plus D over 4 is greater than or equal to the fourth root of A, B, C, D. Yes? And now we can perform the same inequality on 1 over A, comma 1 over B, comma 1 over C, comma 1 over D. 1 over A plus 1 over B plus 1 over C plus 1 over D all over 4 is greater than or equal to the fourth root of 1 over A, B, C, D, right? And now what we can do is multiply these two inequalities together. Don't worry, it's gonna be okay. We can multiply these together. I'm just gonna make this smaller real quick. We can multiply them to get A, B, C. Sorry, my bad. A plus B plus C plus D times 1 over A plus 1 over B plus dot 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 1 over C all over 16. Mind you, we're multiplying the left two sides first. And then we know that's greater than or equal to the product of the right sides, or the fourth root. And note that the ABCDs cancel, the fourth root of 1, which is just 1. Greater than or equal to 1. This means that, if we're going to minimize all this means that from this, A plus B plus C plus D times 1 over A plus 1 over B plus 1 over C plus 1 over D is greater than or equal to 16. We multiplied both sides by 16 here, times 16, to get this inequality, which states the minimum value of what we were looking for. Remember, it's the same thing as here, right? The minimum value is 16, because it's greater than or equal to 16 with equality possible. So we know that this is potentially equal to 16. And that means our answer is 16. Now, how could we do this with Cauchy Schwarz? I just showed you using AMGM. However, we can also dive into how we can use it during Cauchy Schwarz. So we have real A, B, C, D, and we're going to minimize A plus B plus C plus D times the quantity 1 over A plus 1 over B plus 1 over D, right? Or just write dot for multiplication. So we're going to minimize that for real A, B, C, and D. So we can write that this is the square root of A squared plus the square root of B. Note that the square root of A and then squared is the same thing as just A. I'm just rewriting this part right here. So now plus the square root of c squared plus the square root of d squared times, I'll do the same thing here, 1 over the square root of a squared plus 1 over the square root of b all the way to 1 over the square root of d squared. And we've got this, we want to minimize this, right? We've gotten this into the form that Cauchy Schwarz like. A1 squared plus B1 squared plus C1 squared plus D1 squared times, or rather, I should rephrase all that. A1 squared plus A2 squared plus A3 squared plus A4 squared times the quantity B1 squared plus B2 squared plus B3 squared plus B4 squared is greater than or equal to, and note that A1 is the square root of A, A2 is the square root of B. You get the idea. And is greater than or equal to the product of these two plus the product of these two plus the product of these two plus the product of these two, and then all squared. So this is just square root of a times 1 over the square root of a plus the square root of d all over the square root of d, or I guess times 1 over it. All squared. This is what Cauchy Schwarz says. I should rewrite my d. So now, we know that this becomes 1, right? Square root of a times 1 over the square root of a is equal to 1. Same with this term, although I didn't write it, this term and this term. These all sum to 4, and then we square it, making 16. Again, we got the same answer of 16, as in this quantity, which is equal to this, these two are the same, I just rewrote it, is greater than or equal to 16, meaning that the minimum value is 16. And so we have solved this problem using two different ways. I hope you liked today's lesson in learning AMGM, QM, HM as a whole, although we didn't get to use that, and Cauchy Schwarz inequality. This is very crucial to doing competition math at levels such as AME and AMC, and potentially Olympiad levels. Although it may seem simple, I promise you it is very cool. Thanks for listening, and I hope you enjoy your day.